Hello student, I am Arnab Das. Today we discuss about the generator matrix for the encoding of a convolution code. For the convolution codes can also be generated by performing the multiplication of the generator matrix with the input sequence. For the another kind of code, how can you generate that? The same step is following here also. That is, you have to multiply only the generator matrix with the input sequence, that is the u into of g. So if you can able to identify the generator matrix, then automatically you can got the convolution code on there. In this case, the generator matrix is formed in this way. That is the initially you have to identify the generator sequence. So this is g1, g2, g3. If you can able to identify this one, uh, that time the second row will be as a form of the shift single bit towards the right hand direction, so it will be shifted one. Then the second row will be as such, then the third row will be the another one shift. So same thing will be repeated on there, and the number of row will be different, how many number of input bit you are choosing on there for generating the code. Okay, so if the message bit is the 4 bit, that time the 4 row you have to record. If it is the 5 bit, that time the generator matrix row will be 5 on there. Let we consider previously discussed an example for the 2 1 2, and from there you can also generate the generator sequence g1 as a 1 1 1, and g2 is given on there as a 1 0 1. This two we already considered on there. Okay, so from this you are interested to identify the generator matrix. How can you got this one? To do this one, there the generator matrix, little bit thing you have to remember that for your simplicity. That is the, in this case, if you consider g1 and g2 is defined the individual generator sequence. Look that this is the suffix is given as a g1 g2, and the superscript, this is the 1 here also 1, and in this case this is 2, this is 2. This superscript indicate the position 1. Okay, so and the position will be starting from the left hand side to the right hand side, that is you have to go in this way. So this is the position number 1, then this is the position number 2, then this will be the position number 3, and if another one value is present, then it will be the position number 4. In such a way it will be different. Okay, now if you check on there, the g1 is given this one and g2 is this one. Okay, so g11, this one, this is indicate this one value, and g21, this will indicate that this one value. So you have to write down one after one. So this is 1 1. If you check for the value of this one, that is g12, so this will be indicate this one value, and g22, this one is indicate this one value, so it will be indicate the 1 0. If you check for the third one bit position, that time this will be indicate that for the third one g13, this is indicate this one value, and g23, this indicate this one value, so it will be 1 1. So first one you can able to identify the value of generator matrix first row, and that one is indicate that 1 1, this is 1 1 1 0 1 1 on there, and the remaining column position you should have to apply as a value of 0 on there. Okay, now you have to generate the generator matrix, and for this reason the individual row position you have to shift one bit position. So if you shift the one bit position, that time what happened, this next row will be shifted one, and this value will become in this way, this is the shifter. So here the value will be the 0 0. We just omit that 0 on this position, and the third row it will be another one shift, so it will be 1 1 1 0 1 1, and the first, that is the this position and this position you should be apply as the input 0 0. We just omit this one for our simplicity and for our clear image for the generator matrix. So you can also write down the 0 if it is easy for you, otherwise you can left this one as such. Okay, so now we consider a input sequence, that is the input sequence is given to you as a form of 11101. So here number of input bit is 5. So how many number of row you have to consider for the generator matrix, and that one is the 5 on there. So 5 row will be, this is one row, first row, this is second row, this is third row, fourth row, and this is the fifth row. So there are number of 5 row you have to consider on there. Okay, so first one we considered there for the generator matrix is this one, and how you can got this one you can able to understand. And this one for the second row will be shifted one bit one after one. Okay, so this is the ultimate generator matrix, and this one the uh, u, that is the input, and that is 11101, and you just multiply these two, the general formation by which you can do the multiplication for the matrix. So if you consider for the first column for the generator matrix, then look that this position 0, here 0, this one also 0, and the last one position also 0. That means only the first row and the first column position is 1 1, and the remaining are 0. So in here for the input sequence, if you multiply this one, so this position will be as a 0, and the output will be depend only by multiplication of this one with this 1 1. So it will be result as a 1 1 on there. Now if you consider for the second column on there, so this is 0 0 0, so last three you not required to consider, so last three not required to consider. So here only the two row position you have to consider on there, because this input are as a value of 1 1 on there. So this is multiplication you have to do, and then addition on there. So this is for the 1 0 and 1 1, if you add them by using the mod 2 operation, so this will be from the LSB side 0 1, it will be 1, and from the MSB side this is 1 1, so single bit the value will be 0 on there. So ultimately for 1 0, for the value of 1 0 and 1 1, the result will be 0 1 on there. Now you have to check the third one column for the generator matrix. So look that for the third one column, this position is 0, here also 0. That means two row position, last two row position you not have to consider. So this is not have to consider. So here 3 bit position, that is the 3 row position, you have to multiplied with this 111, and then the result will be after mod 2 addition on there. So what will be the value? So first LSB side, if you consider, the value is the 101. So 101, the result will be 0. So this is written here 0, and the MSB position, this is 1 1 1, 3 times 1, so answer will be the 1, and for this reason here the value is given as a 1 0. Same way you can consider for the fourth fourth column position for the generator matrix. So what happened on there? For the fourth row position, look that here the value is 0, here the value is 0, and here also the value is 0 for this particular row position. So what will be? So this one not required to have to consider, this one not have to consider. Okay, so check that here also 0 is present, so this one also not required to consider. So you have to add between these two, that is 1 1 and 1 0. So for the 1 1 and 1 0, the result will be 0 and 1. So for this reason it is written as 0 1. Why this is 0 and 1? If you consider for the LSB position, that time this is 1 and here this is 0. 1 and 0, the addition will be the 1, this is written in this. And for the MSB position 1, and here also this is 1, so 1 and 1, the value will be 0 on there. So this is written as a 0 1 on there. Now if you consider for the fifth one position, so for the fifth one position, the value for the row position, this is 0, this is 0. So first two u position you not required to add on there, and this one also has 0, so this one you should be omit on there. So add between this 1 1 and 1 0. So if we add between 1 1 and 1 1, that time the addition result will be 0 0 because this is the mod 2 addition. Okay, now you consider for the sixth position. So what will be the value on there? So in this case the value will be, previously we have to consider this is 0, this one is 0, this is one is also 0. So this 3-bit position is not required to required for addition purpose. So here also this is 0, so this is not required, also this one. So only the result will be the 1 0. So this is 1 0 is written on here. And the last one cases, look that for the last one cases, there this one 0, that is 4-bit position is 0 on there. So this is considered, not have to consider. So only the last one is the 1 1. So this is written as a 1 1 in this position. So by this way, you can able to generate the sequence, that is the encoder sequence, and which is define the output also for the convolution code. So look that this is the convolution code you can able to generate on here by using this U into of G, that is the matrix multiplication with the input with also the generator matrix on there. Now we consider the same type of thing for the another one example, that one also discussed previously, and from there we can also generate the sequence, and by that particular sequence we are interested to design the generator matrix. And how can you generate the convolution code, we just discussed now on the here. So here the convolution code is 323 and the generator sequence is given this one, this one. So G11, G12, what is specifying on here for the generator sequence? The upper side one, it is indicate the input one, and the below side of this one, this is the output one on this case. So in this case, what will be the formation will be come on there for the generator matrix? Check on that. So first one is the how can you got this 1 1 0, sorry 1 double 0. This will be defined for the first position is 1, then this is 0, then this is 0. So this is 1 0 0. Now for the second one, why it is come as a value of 0 0 1? Due to the reason of this is 0 for the first input, 0, this is 0, this one also 1, so this is 0 0 1. So why the last one in this case it is come as a value of 0 0 0? So due to the reason of this is 0, this is 0, this is also 0, so this is written as such. Now you have to check that for the another one combination on there, that is defined as a form of G1 as a superscript 2 is equal to 0 0 0 G22. This is defined as a 1 0 0 Z32. This one is indicated as a 0 1 1. And from the here, how can you generate the generator matrix on there? So check that how you got this value as a 0 1 0 on there. So look that here the first bit position for the G12 is 0, then this is the 1, and the G3 position, this is first bit position, this is as a value of 0. So this is 0 1 0. So for this reason it is written as 0 1 0 on there. For the second bit position, why it is written as a 0 0 1? Due to the reason of that, here the second bit position for the G12 is 0. For the G22, this is value also 0. For the G32 position, this is also 1. So this will be 0 0 1. This is 0 0. This is 1. So this is written as a 0 0 1. And the same thing is following here for the last one, that is given on here as this is 0, this is 0, this is 1. So this is 0 0 1. So you can able to identify the first row for the generator matrix, and the second row position it will be just only shift the single bit position. If you single bit position you just shift on there, that time that one will be repeated one after one, and it will be follow the ultimate process whatever I will be discussing here. And the number of row will be depend on how many number of input bit you are choosing on there. If the input bit is there 4, that time number of output sorry in here row will be considered for the generator matrix, it will be as a 4 1 on there. There you have to draw the 4 as a row for the generator matrix. If there the input is the 3, that time the 3 as a form of the row you have to consider. Now in here we check that what will be the encoded code for a message bit which is given as a 1110. Okay, so here how many number of input bit is used on there? Total is 4. This is looked at the number of total bit for the U is 4 on there, that is 1110. So you have to uh, write down the total 4 row for the generator matrix. This is the first row, this is the second row, this is the third, this is fourth row. You have to consider one. And what is the process? By shifting one bit one after one. Look that the shifting operation is going on there, and the right shift is occur on here. And then the general process we have to multiply this. So here if you check, and that time this position is 0, this row position is 0, this row position is 0. So you have to not have to consider this section, only that one will be directly come as output this position. How can you got this one? You just add between these two by mod 2 addition. So what will be 0 1 1, it will be the addition result will be come on there. Now, if you consider for the second column position, that time what happened for the second position? This one 0, this one is position is also 0. So these two position not have to consider. So if you just add it between this, then what will be the result? For the first LSP position, it will be 0 because this is 1 1 0 0. So this is 2 times is 1. So this is 0. Then look that for the middle position, for this middle position, there only the one single time is present. So this is 1 on here. And the MSB position, this is also single time 1. So this is 1. So ultimately, the result will become on there as a 110 on there. Now for the fourth position, if you check that time what happened here, this is the 0 on there. So this one not have to consider. So these three you have to add on there by using the mod 2 addition. At the LSB position, there 3 times is 1. In this position 1, here also, there also. So there 3 position is 1. So if you 1 plus 1 plus 1 added by using the mod 2, that time the result will be 1 on there. So this is 1. And there for the middle position, there only the single time is 1. So you have to write down a 1. Remaining are 0 on there. So 1 plus 0 is the 1 will be on there. And for this reason, it is written as a 1. And the same thing is repeated for the MSP position, and for this reason it is 1 also in this position. So the result will be 111 for this position. And now for the fourth position, if you check that for the fourth position, here the value you have to apply as a 0 because here no data is applied on this. So you have to consider here as the value of 0 for the generator matrix row position. If you consider this one, that time this position not have to consider, only these two position you have to add. So these two you have to add, sorry, and this two have to end there. So what will be 111? So this will be 1, and the remaining two position it is 0. So this is 0 on there. So ultimate, this is the process by which you have to do the encoded vector or encoded value for the convolution code. And I think each and everyone get able to understand, though there are another kind of example also I just introduced in here, that is defined as a 3 2 sorry 3 1 2. This is the convolution code where the generator matrix is this one and this one is given. Find the constant length. So it is so easy, that is the single bit position, what will be the formation is come on there, that will be defined the constant length. So what will be this one? This will be indicate with the value of the this one. This is the formula was that n, this is l plus of m. For the constant length l have to consider as a 1, so this is written as a n m plus of 1. And why this is as a from this one? Because for this question their n is given, that is the input line is given on their 1. And initially if you just write down the what is the significance of this one, so first one is defined as the n, second one is defined for the k, and third one is defined for the small m. So n is defined how many number of output terminal is present or line is present. So in this case, this is 3. K is defined how many number of input line is present. In this case, this is 1. And 2 is defined how many number of memory unit is present there. So this is 2 in this case. So from there, you can know that n is 3, m is 2, and k is 1. So you just put this value to calculate the constant length at the value for the L. It will be 1, that is the L is the single one, and m will be defined as a 2. So this is n is written as a 3, m is as a 2, and L is defined as a 1. So ultimately result will become as constant length value will be as a 9. So what will be the rate on there? Rate will be defined the k by of a. K is defined the how many number of input line, in this case 1, and n is defined how to is the output line. So this is case 3. So 1 by 3 will be the result on there. Okay. So how can you generate the diagram one? So for this reason you have to check the generator sequence. So here this is the 110. So what will be the p1 p2 will be present, p3 will be not present. So that look that for the v1, this one is directly connect, this one p2 also connect, but p3 is not connected in here to generate the v1. Now you have to check for the v3. Look, this is the 101, that is p1 present, p2 not present, p3 present. So p1 and p3 will be present, p1 and p3 is present. So for the v2, for the v2, this will be p1. This is look that p1 is present and p3 is present, but this one section is not connected with the summer side or other side. Now for the third one, that is the G3, it will represent as a triple one. So that is P1, P2, P3, each and every one will be added with the summer circuit. So look at this is each and every one, P1, P2 and P3. So this is the V3, and this is also represent for this kind of convolution code encoder diagram. So this is the encoder diagram for the 3, 1, 2 convolution encoder. Okay. The fourth one is that you have to generate the generator matrix. Fourth one, that is question number D, generator matrix. Generator matrix, already you have to identify this one, and this one. So first one value will be the 110. So this will be the 1 because the this is 1, this one also 1, this one also 1. Second one value will be what? This is 101, this is 1 this position, this is 0 this position, this is 1. So this is 101 will be there, and the last one will be the 011. So this is 011. So look that this one is repeated in here. Look that this is triple one, then 101, this is 010. So after that you have to shift one bit position. So for the one bit position shift, it will be as a second row will be as a same thing for the previous one line. This is 111, this is 101, this is 010, and the number of row will be depend on how many number of input bit you are choosing on there. So I think each and everyone can able to understand and able to identify what is the formation you can got this one. And time domain approach also will be the same thing, where the u is multiplied with the g. U is the message bit, so this is the message bit, and g is already given to you in this question. This is 110. So if you multiply this, then this will be the convolution multiplication, and then the convolution result will be this one. After that you have to just write down one after one. So this is 111. For the second one position you have to 010. So this is, and if you consider for the last one, so this is 011. So this is as such. So time domain approach, what will be? For the time domain approach, you have to just write down the generator sequence into the form of the polynomial. So for the equation was for the g is given as a 110. So this is 1 plus of x. For the third one, sorry, second one, it is given was as a 101. So this is the 1, and this will be the x square. And the third one is given as a triple one. So this is 1 plus of x square will be. Okay. Now you have to multiply to get the output. For the v1 x, it will be multiplied with the u into of gx. So u is defined as a form of 1 1 1 0 1. So here 1 plus of x square plus of x is 4. So this is written in this case, and g1x already you got the polynomial, and then if you multiply this, then ultimately result will become this one. And you should be remember that mod 2 addition also applicable in this case. Okay, so same way you can also generate for the v2. This is ux is this one, and g2x already calculated, so if you multiply, then the result will be this one. For the v3 also same way you can do the process, and ultimately you can got the code vector or code polynomial as such. Okay, so what will be the polynomial output? Polynomial output will be, this is the v of x to the power of n, that is the x position you have to uh, put the value of x's cube. Why this is x's cube? X to the power n, here n is the 3, question is given. So this one, if you put the position of x as x to the power cube, so for the first one this will be the value. For the, again I just repeat that, x position you just put the value as the x to the power of n. Here n is defined 3, so for this reason x to the power 3 you have to put on there. So this will be the result. And why this is written as a 1 plus of x square is multiplied in this case? Because you are considering the 3 as a value on there. Okay, so here this is the 1 is multiplied, this is x is multiplied, this is x square is multiplied 1, this is 1 1 1 is applicable on here. So if you multiply this 3, that time the result will become this one, and ultimately process one after one. So this will be the value this one, and you just write down the coefficient now. So that is the encoded value for the convolution code. I think each and everyone able to understand, and this is an example you can also try as if for your home tasks, and hope each and everyone can do this one. And for the next day we will come together with a new topic. Till, stay safe, have a good day.